Welcome to the video on the derivative of the natural log. In this video we're going to find the derivative of the natural log, and we're going to solve some examples applying this new derivative. So we're going to consider the function f of x equals the natural log of x, and we're going to try to find its derivative. And the only method to find the derivative of a new function is to apply the definition of the derivative. So this is the definition. The definition is the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. So in this case our f is the natural log, so here we replace it. And now we're going to use some basic properties of natural log. Here we have a difference between two logarithms, and there is a basic property that says that you can transform this into the natural log of the quotient of these two numbers, like this. So we do that here. Now we can write this as like this, taking the 1 over delta x over here, and we have that times the natural log of this number, and this number we can write like this as 1 plus delta x over x. If you here well, this is just another way to write this same expression. And now we're going to apply a second property of logarithms that says that you can take this number here that is multiplied by the natural log and take it here as an exponent, like this. We just took this number here and put it here as an exponent. So now our problem is to solve this limit, and there is a very useful technique that it consists of trying to make the number e to appear there in our expression and replace its definition by the number e. So that's what we're going to try, and to accomplish that we're going to make this substitution. We're going to introduce the variable n such that 1 over n is delta x over x. And here we have also 1 over delta x, so we need to solve for 1 over delta x. If we solve for it using this equation, we have that 1 over delta x is n over x. And we also need to solve for n, and if we solve for n we get that this is x over delta x. So here we need to know that here we have a limit as delta x approaches 0, but we need to have a limit in terms of the variable n. So what does n approach as delta x approaches 0? As delta x approaches 0, well, delta x is in the denominator, so as it approaches 0, well, x is a constant here, so as delta x approaches 0, n will approach infinity. Well, we need that because we're going to write this limit as a limit where n is a variable. N is approaching infinity. And delta x over x is 1 over n, and 1 over delta x is n over x. Here x is considered a constant. So we now have to solve this limit here. And using just the properties of exponents, we can write this factor here like this. We take the 1 over x outside, we just separate the exponents here. So here we can use again a property of the natural log. We have the natural log of something to some exponent. So the natural thing to do is to take that exponent down here. Now here we have a limit where n is a variable and x is a constant. So we can, as a function, also because the natural log is a continuous function. So in that case you can change the order between applying the function and taking the limit. Here we first apply the function and then take the limit. But here we can change the order and first take the limit and then take the natural log. So here we take 1 over x out of the limit sign and we change the order. First we take the limit of this expression and then we take the natural log. We can do this only because the natural log is a continuous function. But look here, this is interesting. Here we have, what we have here is the definition of number e. So we have that the derivative of the natural log is this expression. Here we have the natural log of a number e, but by definition of the number e, this is 1. So we get that the derivative is 1 over x. And I find this result pretty interesting because it doesn't fit into the pattern. Because if you have the function f of x equals x, its derivative is 1. If you take the function x squared over 2, you have that its derivative is x. And well, if you take a function x to the n, where n is any exponent, you have that you'll expect that the function whose derivative is x to the n will be a polynomial function like this one. But it happens that when the exponent is minus 1, that is, when you have the function 1 over x, the function whose derivative is 1 over x is not a polynomial function. It is a natural log. And I find this very interesting because it breaks the pattern. Here we have polynomial, and out of the sudden you have natural log. So let's do one example here. Here we consider this composite function. We have the natural log of a times x plus v. Here a and v are constants. So here we need to apply the chain rule. This is an exercise in applying the chain rule. So to find the derivative of this function, we need to take the derivative of the outer function, that is natural log, but evaluate it at the value of the inner function. So we have 1 over ax plus v, and we need to multiply that by the derivative of the inner function, that in this case is just a. So this is the final answer. So this is just a very simple example. In the next videos we're going to solve more involved examples using the natural log. So that's all for now. Thank you for watching and see you next time.